first, who here has used Kubernetes before? I'm hoping it's most of the room. All right. Who here has dealt with access control in Kubernetes? Smaller part of the room. And who here is ready for lunch? All right. So we're going to go quickly through this because I know you guys are all hungry. All right. So who am I? I'm Joey Schorr. As mentioned, I'm CTO of AuthZed. AuthZed, we build the premier fine-grained relationships-based permissions database called SpiceDB, which is based on the Google Zanzibar paper. Who here has read the Google Zanzibar paper or knows of it? All right, so we're going to be talking a little bit about that later on in the presentation. So let's talk about Kubernetes authorization today, why it's important, and why it's somewhat problematic. So why is access control or authorization important for Kubernetes? Well, Kubernetes clusters are often shared amongst different silos of resources, applications, groups, teams. You can even have tenants. We saw a great talk earlier about containerization and user namespacing. Well, this means that if you configure your cluster correctly and don't have too many security vulnerabilities, you can run separate tenants on a shared cluster. As a result, it's often critical to have proper access control to ensure isolation between those various silos, because you don't need just isolation at the application layer, but at the infrastructure layer. The people who are managing Kubernetes as well may only have access to a subset of resources. But for optimization and cost perspective, you may still want it to be a global Kubernetes cluster. So what are the options today? Well, Kubernetes has 3 or 4 built-in access control technologies today. I'll go through them very briefly. Note this is not a comprehensive overview of all of the different options. I'm giving a kind of like high-level overview. If you have any additional questions, feel free to ask. So the 3 main available authorization methods today are role-based access control, or RBAC, attribute-based access control, or ABAC, and webhook control. There are a few other ones around admission controls and a few other things there. Again, I'm not going to go too deeply into the other options. These are the 3 main ones that people mostly use today. And we'll talk about what the pros and cons of each are. So first, let's talk about role-based access control, or RBAC. This is similar to any other mainstay RBAC that you may find in another application. There exists a set of roles. Each role defines 1 or more rules that says these are the resources or resource types and the various verbs that you can perform on those resources. And then you bind a role via role binding to a subject, such as a user. So as an example here, this is an example of some of the YAML you might create in Kubernetes. You would create a role, say pod reader. This was taken directly from the Kubernetes documentation, so shout out to them for writing this. And you can say that the pod reader can get, watch, and list. These are the actions or verbs that they can take on resources of type pods. Pretty straightforward. And then you have a role binding. In this case, it's called read pods. And it allows user Jane to have the role of pod reader. And by virtue of the fact that Jane is a pod reader, and a pod reader can, say, list pods, if Jane then is authenticated to the Kubernetes cluster and does, kubectl get pods, by walking from the subject to the role binding to the role to the rule to the resources and verbs, Jane will therefore be able to list all of the pods in the cluster. And now note, these resource lists don't have to just be by type. You can specify specific resources here. However, it just makes the file more verbose. So what are the benefits of this? Well, RBAC is pretty straightforward to use. You just create a couple of custom resources, basically, in the cluster. It's easy to map users to roles. Just create a role binding. It's easy to match specific resource types and actions. We just saw a very simple but powerful example. But it has a number of downsides. The first one is it's fairly coarse-grained. You can do some more fine-grained matching if you're very careful, but in general, you're only going to be seeing role bindings usually at the resource type level, maybe at particular labels. It does not allow for complex rule sets. So you can say, I want this user to have this verb on this resource, but you can't say, unless it's a Tuesday. Now, I don't know why that would be important, but you never know. Policy may be required for some corporate structure that says people can't access certain things on the weekends. No Friday deployments, exactly right. Most roles are often one-off, and usually as a result, you get a huge combinatorial explosion of the number of these resources in your cluster, and then for managing and these roles becomes very, very difficult. And most critically, its inability to easily filter lists or watch. Kubernetes built-in authorization, we'll see this for all the other options too, does not have a very simple way of saying, if you do, say, kubectl get pods, of it just returning just the pods that you can view. There are ways to do it with some labels that have been coming down the pipeline, but as of today, the built-in authorization methods are very coarse for this. And that can be a problem if even the name, say, of a pod could be leaking sensitive information. The next option here is attribute-based access control. This grants access to resources and actions based on a policy that you write and store in the cluster. So the diagram is pretty simple. Hey, look, it's just a policy. Great. But encoded into that one box is actually a lot of complexity. So first, as an example, here's a policy that says user Bob for resource pods can read them. Pretty straightforward. But this has a number of downsides as well. So on the upside, it's more powerful than RBAC, right? You can define more complex rules almost to a point of arbitrariness. It has a single definition for controlling access, so you don't have to go looking for things. As I said, it allows for some more complex rule sets. However, it has a number of major downsides. First, it's fairly verbose. Now you're shoving everything into a single policy, which means it can also grow quite large. Now, that's better than before where you had lots and lots of little role bindings and roles, but now you could have this truly massive policy. And as we've seen in earlier talks today as well, right, having a truly massive policy can become a problem. One of the major downsides of the ABAC approach as well is it has to be statically defined once at cluster startup. You can't dynamically change this on a cluster easily. That's a problem if your access controls are changing over time. There are ways around this. Again, I'm not going to go too deeply into that, but it is a major downside. And again, the inability to easily filter lists or watch. Webhook control. This is probably the most flexible of the mainstay options. It grants access to resources and actions in Kubernetes based on making a call to an external webhook. It can kind of do anything you want it to. So Kubernetes will just make a REST call over to a webhook that you specify, and you return yes or no, or true or false, or has permission or not, depending on the language you prefer. And Kubernetes will just act on that. So in this case, we're going to define a subject access review. We're going to say that Jane, when she tries to get pods, call this endpoint. I've elided the endpoint definition here because it would make the on-screen view too big, but you would give it an HTTPS URL, and you receive a JSON blob saying this is the user that wishes to perform this action, and then you can respond with status allowed true or false, or an error. And the system will just agree with you. Now, that's super, super, super powerful. You can kind of do anything you want. It allows for arbitrary and external decision making, but it requires a dependency on an external service as part of the kube core. This could be a problem if, let's say, for example, your external service goes down and now you cannot fix your Kubernetes cluster because you have no access. That's a problem. It's only as powerful as the engine driving it. Now, there's some very, very powerful authorization engines out there. I mean, I'm going to show you one in a minute. But it's still something you have to be aware of. And then again, inability to easily filter lists or watch. So these are the current built-in options. All have some pluses, all have some minuses. But what if we could do better? So let's talk a little bit about SpiceDB. So what is SpiceDB? SpiceDB is Ofsted's open source implementation of the Google Zanzibar paper and permissions paradigm. It's based on this concept called relationship-based access control. It's open source. Feel free to QR code the project there on GitHub, or just go to spicedb.io. It'll direct you there. Please star. And relationship-based access control allows for high levels of flexibility while also allowing for fast computation and operations such as listing. For those who haven't read the Zanzibar paper, and it seems like it's the majority of the room, Google built this concept, this paradigm, to power all authorization decisions at Google. Not just specific applications, but the entirety of Google itself. This is, for example, why if you have a Google document and you paste a link into a Gmail and send it to somebody, Gmail can return and say, hey, that document isn't shared with that person. Would you like to do it? How does Gmail know what Google Docs permissions are? It's because they're all sitting on top of Zanzibar internally at Google. And this powers decision-making on the order of hundreds of millions of QPS and billions of relationships. So it's designed for scale and fast computation. Since we don't have a lot of knowledge in the room as to how reback works. I'm just going to give a very, very high-level overview. If you're interested in more details, we'll talk about it later. But the basic idea of relationship-based access control is you define a schema, which is the structural idea of what the data for relationships is, as well as how to compute permissions, and then relationships, which define the actual relationship between objects. So in this case here, we can see we have a user, that's a subject type, and a document. In this case, we're mimicking RBAC by saying there's two roles, a writer and a reader, both of which can link to a user. The permission to edit the document is if you have the writer role, and the permission to view the document is if you have the reader role or the edit permission, and this allows you to reference other permissions, etc. And then I've defined three relationships here. Tom is the reader of the first document, Fred is the writer of the first document, and Fred is a reader of the second document. So on the surface, it's fairly straightforward. You just define how you want your permissions to be computed and what relationship kinds can exist between objects, and then you define your relationships at runtime to say these are the actual relationships that exist. As a more concrete example of a slightly more complicated schema, we have here a document which lives under an organization. It has two roles, for lack of a better term, an owner and a reader. And the ability to view the document is you have the reader role, the owner role, or you have the can admin permission for any organization that the document lives under. This schema forms a graph, and this is how reback actually works. It's all graph-based, that is roughly analogous to this diagram behind me, where the document's view permission points to these three, what we call relations, reader, owner, and org, and then the org in turn points to an organization, the can admin permission, and then admin. And the way you actually compute whether a permission exists once the relationships are placed inside is you walk a path. So when you're trying to ask, can a particular subject view a document, you're actually starting at that permission and looking if there's any paths that exist between that permission and that subject. So in this version of the graph, we've added in some actual concrete relationships here, and I've color-coded them for ease of view. And you can see that the relationships actually allow us to form real paths between the document's permission, in this case view, and the various subjects. So to animate this, here, if we were trying to ask whether Fred can view the document, we would start by walking from subdocument view, and we would continue through all of the relations, but in this case we go to reader, and eventually we'd see Fred, and by virtue of finding that path, Fred therefore has the view permission on the document. This kind of relationship and access control allows for very, very, very powerful definitions to occur. For example, as we see here, you can already do things like walk to a parent organization and then check permissions on it. It supports recursion, so you can have folders and folders and folders. So this is very useful if you want to have different organizations. You can have multiple parent folders, etc. This is all supported by a reback model. So what does this have to do with Kubernetes? Well, what if we could use SpiceDB to perform access control for Kubernetes, but in a way that was safe? So let's talk about that. We built a proxy called the SpiceDB Kubernetes API Proxy. Pretty descriptive name, I had to say so myself. And what it does is it allows you to make any Kubernetes API call to the proxy, which will then use SpiceDB to answer access control questions, and then forward the requests onto Kubernetes. There's a few key points here. First, because it speaks the kube API, you can use it with any tooling. I'm going to demo actually in a moment using it with kubectl, but anything that speaks the kube API will work. The second point to note here is because it's a proxy, if there's ever an issue with, say, SpiceDB, or you want to bypass the proxy, as long as you have direct access to the kube API, which of course you would keep locked down for normal users, you can always just bypass the proxy and do whatever you like within the Kubernetes API itself. This is not something that Kubernetes calls out to, so it's not a hard dependency. Instead, you're going through it. And you can, of course, run this and SpiceDB HA if that is a concern. So the kube API proxy is also open source. Again, feel free to take a look at the source code. It's written in Go. Here's a QR code if you'd like to take a look at that. But I'm going to be showing a brief demo about it, and then I'll show you how this makes management of fine-grained access control in Kubernetes a lot better. So how does it work? First, you configure the proxy. The proxy has what's known as proxy rules. And each proxy rule is a custom resource that you put into your Kubernetes cluster. And after running the proxy as a service, it reads these rules. And the rules specify two concepts. The first are checks. So if you want to say, for example, have the get verb on pods, you can say, in order to have the ability to get a pod, the permission check pod with the namespace name of the pod, view permission must apply to this user. In other words, whatever user is requesting to view a pod must have the view permission on that pod in SpiceDB. And similarly, there are create operations where you can say if a pod is being created, you can write a relationship at that point. So in this case, if a user creates a pod, a relationship is written as them being the creator of the pod. Pretty straightforward. And this allows us to use standard kubectl operations and have SpiceDB's relationships be updated in real time, as well as using the checks accordingly. What about listing? So unlike the built-in Kubernetes authorization systems I spoke about earlier, the proxy supports filtering and watch out of the box. And this is by virtue of the fact of SpiceDB having an API called lookup resources. One of the major benefits of a relationship-based access control paradigm is if you can walk the graph forward to find out if a user has a permission, you can walk the graph backward to find all the permissions the user has on all resources or of particular types. So being able to take advantage of this, we can say for listing and watching in Kubernetes, just do a lookup resource of, in this case for namespaces, all of the namespaces that the user has the view permission on. The system, SpiceDB, will return a full list to Kubernetes, and then Kubernetes can just display that. So this allows you to have a truly filtered, holistic view of all of the resources of a particular type without having to do any additional work, which is very, very powerful. So let's take a look at a demo here. This is already running on my machine, so hopefully it works. I also have it tethered to my phone, so if it needs internet, it should be good. But since my phone is from the States, it may have to go through a couple of hops, so we'll see. So I have the proxy running right here, and you can run this right now on your laptop using mage dev up. Let me know if this is too small, and I'll make it bigger. I'm sorry? Oh, yeah, hold on. Let's see if is that a little more readable? All right, cool. So I have SpiceDB running right here, and you can see all of the logs that it's outputting. I've turned on the logs of all the API calls that it's being made, just so we can watch it as we go along. First, I'm going to do something. Sorry, I don't know where it went off screen. There we go. Right. So if I do kubectl get namespaces, there's only the namespace of the proxy running, and if I go back to SpiceDB here, you'll see it actually made a lookup resources call. So that was actually asking SpiceDB which namespaces I, as the user, can view. And if I go to SpiceDB itself, we have a command line tool called Z. I can actually ask it to show me all the relationships that exist for the namespace object. In this case, there's only one, because that's the one namespace I have created so far. So I'm going to create a new namespace here. Create namespace test. All right, and now if I get namespaces, you'll see both are present. If I list the relationships, you'll now see two more relationships up there. So the proxies created two relationships in SpiceDB, one with me as the creator of that namespace, and also with a cluster object on it. This is useful if you want to be able to do stuff like grant permissions at a cluster level as opposed to individually on the namespace. And then if I go over to SpiceDB, you'll see here a bunch of operations were run, including write relationships, read relationships, lookup, etc. So I'm going to create a pod now. Create -f. Forget what I called it here. Simple pod. kubectl get pods. All right. Oh, and test. All right. So I have my nginx pod there that I just created in the test namespace. And now if I list the pod relationships here, we'll see that the pod test nginx creator was set to me, which is super useful. Now what I'm going to do is I'm actually going to put a watch on this pod list here. And I'm going to put this over to the side so that we can watch it change in real time as I make other changes. So I'm having this watch that. Now, if I were to say go in here and first delete the relationship, delete, and let's say I were to delete myself as the creator of the pod. By virtue of having myself as the creator of the pod, I can view that pod. But if I delete myself, give it a second. Come on. Right. So it just deleted myself, and now there's no resources found. Now that pod's still there, but because I deleted myself as the creator of that resource, I no longer have permission to view that resource, and therefore it's come out as an empty list. So I'm going to put myself back in there so I can just see the pod again. All right. Now, likewise, you can make changes to the access control schema itself in real time. So I'm going to go over here to VS Code. And the current schema that we're using is here found in Bootstrap. The ability to view a pod is if you're a viewer or a creator. But I'm going to change the schema so that if you're a member of a team that has the ability to view the pod, you can also view the pod. So what I'm going to do here is I'm going to go back and delete myself as, so now I can't see it again. Then I'm going to Z schema right. And I'm going to, this is in package, SpiceDB, new schema. Okay, so I'm updating the schema in real time. Now, you notice nothing changed. The system can just keep moving forward. Now I'm going to create a relationship that says pod test nginx has a viewer that is a team, I don't know, call it foo. Oh. It's a relationship create, not create relationship. Live demos are fun. Okay. And now I'm going to add myself as a member of that team. So I'm going to do create team foo member user Rakus. And as soon as I add myself to the team, my pod showed up again. So I'm not actually right now a direct viewer of that pod, but by virtue of being a member of a team who is a viewer, by the transitive property of the graph walk, I once again have access. Similarly, let's say I wanted to have it so that members of the organization that owns the pods, there's no concept of an organization necessarily in Kubernetes, but let's say I wanted to have organizational structure on my Kubernetes resources, and I wanted to have it so that any member of an org that was the owner of the pod could view it. So here I'll add plus organization view. The arrow here says walk any organizations to the view permission. So I'm going to, again, remove myself from the team just to make sure that I lose access. Give it a second. It's running around off the internet here, so it's a little slow. There we go. I'm going to update the schema to the one that supports organizations. New schema 2. All right, and now I'm going to grant the organization on the pod. So this will be pod tests nginx organization. I'm going to call it organization bar. And then I'm going to add myself as a member. Organization bar member user Rakus. And the pod shows up again. So in this case, we've walked from the pod to an organization to myself. But you don't have to have a single organization here. You could, in fact, have multiple organizations, or you could have nested organizations or nested folders, etc. I'm not going to show all the different combinations of what you can do with relationship-based access control today, but what I wanted to show was at any point, the system is reacting in real time to SpiceDB, using SpiceDB to actually make the permissions decisions as we see here on the API calls. And by virtue of being able to even just change, and actually I'll show this in real time, if I go back to the original schema here, well, I'd have to delete it. So I'll actually just drop this part of the schema here. I'll remove the organization view. Right? And I lost access. I didn't make any changes to the relationships there. So you can change the schema as well. Usually you wouldn't do this because you don't want existing users to lose access, but for demo purposes, I thought I'd do it. And so you can leverage all the power of reback, and your Kubernetes systems will just continue working as expected. So let's go back here. What are the benefits and downsides of the Kubernetes API proxy? Well, it allows for fine-grained permissions and complex decision-making. We saw only a very, very tiny amount of what the power that exists in SpiceDB is. One of the really nice things about SpiceDB's reback implementation, and something that we pioneered, is something called caveats, which lets you mix attribute-based access control in addition to relationship. So you can have relationships that say, this user is a viewer, but only on Thursdays. Or this user is a viewer, but only if they have this additional key. all of that is built into SpiceDB. The caller, in this case, the Kube API Proxy, doesn't even need to understand that. They can just ask yes or no, or maybe. It's built on top of SpiceDB, which, as I mentioned, is designed for scale and performance. In this case, I'm running SpiceDB on my laptop, but nothing would preclude you from using also dedicated art offering or running it yourself in a very large cluster. And we've seen QPS counts in the millions or more, actually higher than that, but I'm not at liberty to say those numbers. But the point is that for any Kubernetes cluster of any real scale, this will handle the authorization no problem. It works with any existing Kubernetes client or anything that speaks the Kube API because the proxy implements the API. Supports listing and filtering. So it's pretty powerful. There's one small downside, which is you have to run a distinct service, but you can run it HA. It is a stateless service. And as mentioned, your Kubernetes is not hard dependent on it. If that service goes down, yes, your users who are using the fine-grained authorization will not be able to access, but again, it's HA, so hopefully it won't. But even if it does, your Kubernetes itself is still fine. As long as you have admin credentials for your Kubernetes cluster, you can always go in there and fix stuff if need be. There's no hard dependency there. Kubernetes will still function. So yeah, that's fine-grained access control for Kubernetes. I didn't want to take too long, but I wanted to leave time for questions or other demos if people are interested. So anyone have any questions? Looks like we've got a few.
First, let's give a round of applause to Joy. Thank you so much.
Hello, thank you for your talk, very exciting. I have a question actually about the deployment. So if I need to run a dedicated, so can I run on the same cluster?
Yeah, I mean, I'm actually doing that right here. So I'm running it in kind on my laptop right now. You can put it in the exact same cluster, and then you just expose it as a port somewhere, and then have your Kubernetes cluster, clients configured to talk to that as its API endpoint. Yeah.
So thank you for the talk. You showed in your demo, you showed using command line to configure SpiceDB. So what's the best practice workflow to keep the configuration up to date? Probably you have an operator. Do you have any Terraform provider? So what's the usual way to program SpiceDB with relationship and permissions?
Yeah. So generally speaking, we do actually have an operator for SpiceDB if you wish to run it. So if you could also run SpiceDB in the same Kubernetes cluster, just drop the operator in and configure it. It does need what we call a backing data store, one of Postgres, MySQL, Spanner, CockroachDB. The one I'm running locally is actually doing everything in memory, which if you don't care about HA is perfectly fine. How you manage the schema is generally done, or it's generally recommended to do so via CI. We have GitHub Action tooling for that. And then the relationships, it comes down to how you want to grant access. So if your access is fairly static, you can load the relationships in at startup of SpiceDB and then just run off of those. On the flip side, we have a full gRPC and on top of it REST API for reading, writing relationships, for reading and writing schema, for issuing permissions checks. And so oftentimes, for most of our customers, they're using SpiceDB as an authorization service from their applications. And so if a user is granted, say, a role or they're onboarded onto a platform, the system will call write relationships in SpiceDB to write that relationship into the backing data store and persist it. So it's really up to you. It's very flexible. If, as I said, it's just something that you wanted to update, from a list of rels and a list of and a schema in CI, you can do that. For most large installations, you would almost certainly have like a management dashboard that would handle the relationship updating from there.
Thank you. Another question?
Hi. So can it also handle custom resources in Kubernetes?
Yes. Yeah. So we actually, just for some background, the reason we actually started working on the proxy itself was because the way we deploy our SpiceDB for our dedicated customers is all done via Kubernetes. And we have a management layer that sits on top of that SpiceDB. And because all the SpiceDB resources are managed via custom resources, we were like, well, we want multi-tenancy in our platform. How do we do it? And so we're deploying the Kube API proxy to manage SpiceDB via SpiceDB. It's a little meta there. It's kind of turtles all the way down. But yes, it fully supports custom resources. It was designed with that in mind, in fact.
Thank you.
Yeah.
Next question.
We have time for more.
Yeah, we got time.
Okay, thank you for the talk. And I have a question about auditability of the system. Can it be made in read-only mode, so that basically permission can only come from Git or something like that?
You can run SpiceDB in a read-only mode. So if you were to preload the relationships into it and presumably put it into in-memory mode only, because then you don't need to persist anything, you could run the SpiceDB pod in read-only mode, which prevent all writes to it, and then yes, it would be incapable of having any of its data changed. Yeah. In terms of other auditability too, for our dedicated product, which is where we run SpiceDB for you, we have our enterprise on-prem version. There is a built-in audit log capability where every API operation, including writes and deletes of relationships, goes to an audit log, and then you can run auditability on top of that.
I don't see questions on the app, so let me know.
In your demo, you showed several times that you locked yourself out. Are there like building controls to not shoot yourself in the foot?
No, but what you would almost certainly do in a real schema that I didn't show in mine is you would have probably a super user or a platform object at the very top, and you would have all of your permissions ultimately flow to that, and then have specialized users and or service tokens that would have root access potentially. One of the very powerful things about SpiceDB, and I can just show this briefly if I bring up VS Code, is if we look at the schema here, we defined a subject type of user here and a subject type of cluster, but there's nothing precluding you from having other subject types here. So you could have service account, you could have access token, you could define them however you want. And if you wanted to have a root permission here, I'm just going to do this off the cuff. I could have a platform here and relation admin here and say a user. And then I could say every organization exists under the singleton platform. And we could say have a permission here that's like admin equals platform member. I believe I'm sorry, I called it admin, platform admin. And then under the pod here, you can do plus organization admin. If we did it this way, then by virtue of the walking structure, and we put, say, a super user here on the singleton platform, that super user would then be an admin of every organization, and by virtue of being an admin of every organization, therefore would be the admin of every pod, and you would probably have plus organization admin here as well. And that means that effectively you're granting every permission to every user. You have to decide that for yourself based on the schema. We have some pre-canned schemas, but again, you can decide how you want this to work. And so that's what's super powerful and flexible about this, is because you could say, like, we're only going to grant access to these particular resource types, and I want it to be, a nested label structure, right? If the user has been granted access to a particular label, then they have access to all of the things in that label. Or you could say, I want all users to have access except this list of banned users. It's very, very flexible. I think there's one in the back.
Oh, voila.
Hi, exciting talk. How does this compare to open policy agent? I mean, is that its own schema? I see SpiceDB. I think it's not JSON compatible, unlike Rego. So I see some similarities. What's the edge? Other than
The fundamental difference here is that, as I mentioned, this is something called relationship-based access control, and it's not ABAC. And so traditionally with things like Rego or other ABAC policy ideas, it's pretty free form. You can kind of write what rules you want. That has power, but it has consequences. Most notably, it has consequences on performance and scale. This was not designed just for 10 users with 100 resources. It was designed for 10 billion users with 1 trillion resources. The biggest downside of policy-based access control is the ability to do a reverse list is effectively impossible to scale. So because you're giving effectively a program when you write a policy, the only way to ask the system for, give me all the things this user can view, is to take each item and run the policy over and over again. Now, There are some ways around that with some clever policy writing, but really it's not scalable. With relationship-based access control, one of the major benefits, in addition to all the aforementioned ones, is we can just walk the graph in reverse. So if I go back to my slides here, and we go back to the graph right here, and I want to ask, give me all of the documents that say Fred can view. Rather than starting at some document view and walking a path to Fred, I start at Fred and I walk back to reader, back to view, back to some document. I found some document. And this is very, very, very important for the reasons I showed earlier, which is if even the names potentially of a pod could leak sensitive information, being able to do that filtered list very, very quickly is very important. And in fact, as far as I know, and don't quote me on this, I may be wrong, but it is my understanding that one of the major reasons that Kubernetes does not do watch and list filtering on its current authorization systems is because it's so hard to do it in a performant way, and this is trivial for us. Now, in terms of ABAC versus reback, there are also a number of other upsides, downsides, but as I mentioned, we do actually support the concept of ABAC within reback, and that's something that we actually pioneered. So let's say, for example, you wanted to say here, and you wanted to say with some policy on the user, you can define what we call a caveat. I'm going to call some policy here. And you give it some parameters, like some condition is an integer. And this is only true if this is 42. I'm obviously making this up as I go. But the point stands is that if you then executed the view permission here and it would walk to the viewer, if you have a relationship that exists in the system like pod, some pod, viewer, at user, Tom, with the some policy attached, this relationship will only be considered existing if the conditions in here are met. So in this case, it's some condition 42. So if you want to have, like, this user only has access on a Tuesday, you would say, like, current day. May make it a string here. And say is equal to Tuesday. And then you would pass the current day in to the check. And the system would only validate or like, you know, resurrect that relationship if this policy is true. So it's less powerful in the sense than like a pure policy because you don't have just willy-nilly to do anything. We've constrained you. For those who are curious, this is actually using Google Cell expressions, so they're not Turing complete on purpose. But it's still very powerful, and by allowing you to mix these two concepts together, you get like 98% of the performance and scale of reback with a little more powerful of ABAC, but it all works together. You can still call lookup resources on this. We'll still do the computation. We have some really, really deep optimizations in there to make it so that we can shear trees early and do stuff in there. And we know that this works because we have customers using it at scales far in excess of what I mentioned earlier. Not that you need that just for your local Kubernetes cluster, but it's nice to know that you can get there if you need to.
And we are at time, so thank you so much, Joy.
Just one other thing I'll mention. Sure. If you guys have any additional questions, we have a Discord. Feel free to jump in there. Somebody from my team, or more likely me, since I'll be in this time zone for a while, will answer. Yeah.